Hello YouTube, my name is Agent Omega, and I do things. Welcome to this mod interaction tutorial slash showcase wherein we're going to go over some create new age, and immersive engineering. We are currently on the creative mirror server of my TEYARA SMP, where I first tested this design and of course built out my base, but that's not important. This that I'm standing on was the initial creative mode prototype that basically encouraged me to build out the rest of the system. I just wanted to see how new age heat plates worked. And so you can see we've got 3 rows of 5 advanced solar plates here, all connected up with heat pumps. And if I turn, where is it? If I turn this crank, we should get a tier 6? Okay, a tier 4 boiler it looks like. And that's because right now, this is just running at, I've got a speedometer somewhere, 96 RPM. So I guess this is running at 48, doubling it to 96. And that means that we're only pumping enough water for a level 4 boiler. But this is still the thing that encouraged me and suggested that, yes, making an entirely solar-powered boiler in order to generate electricity was a viable option, at least in terms of the mod pack that we're in, which is TNP Limitless 7, but this should work in any combination of create, new age, and immersive engineering, as we're going to get to. We are now in one of my creative testing worlds. It's just a super flat desert for the purposes of contraption building, as you can see. Over here, we just have a bunch of the items that we're going to be using in this integration. This is not a fully comprehensive tutorial about New Age or immersive engineering, so some of the items I'm not going to go all the way down the tree, for instance, block of andesite alloy. This does expect you to have a very basic familiarity with create and potentially immersive engineering in order to understand it, but I'm going to go over the concepts as best I can. And of course, if you want anything explained in more detail or want tutorials for these specific mods, then let me know. I know there are a bunch out there on YouTube already, but sometimes people like having an additional take because there may be information that other tutorials don't provide. But let's get on with it. Let's start with some of the create new age things that we're going to have to build out, starting with our generator coil. It is a block of andesite surrounded by copper ingots. Next on the list, we have carbon brushes, my apologies. This is what you use to extract power from generator coils turning through magnetite. That's going to be your starting magnetic coil like we have here. There are more advanced materials, but we're not getting into it in this mod integration. You can build these with a row of andesite alloy, coal, shaft, coal, and another row of andesite alloy. Next up is the basic Energizer. This is simply an andesite casing and a lightning rod. I don't know if you need this exact layout in the crafting bench. I don't think it's exactly shapeless though, so I'm pretty sure you do at least need them next to each other like this. Moving along, we have the basic motor from New Age. Row of iron nuggets, a magnetite block, andesite casing, shaft, and another row of iron nuggets. If you want to be upgrading your motor to the strong motor, you're going to need instead gold nuggets, an overcharged iron ingot, which we're going to get into shortly, brass casing, shaft, and another row of gold nuggets. Next on the list is the basic solar plate. This is exactly what it says on the tin. It generates 20 degrees T per second. Still haven't figured out what the degrees T is. Maybe like thorium or thorad or something like that. I don't know. But we have a row of glass, iron ingot, heat pipe, iron ingot, and then again, iron ingot, heat pipe, iron ingot. And speaking of heat pipes, that's the next thing. These are used to transfer heat throughout the system. These are omnidirectional as far as I'm aware, meaning they can connect in all 6 axes. They also are undirected, so I think this would theoretically permit heat to flow backwards if, say, some area over in this side of a system got hotter than an area over in this side of the system. It would allow heat to flow backwards this way. But that is simply zinc nugget, terracotta, zinc nugget. And then terracotta, copper plate, check your JEI, this can probably be from any mod, but just be careful. And then terracotta. Next we have the heat pump. This is one directional as far as I'm aware. This effectively makes sure that heat transfers in the direction the arrow is pointing, meaning it is very useful to break up cycles in your heating system, and also ensures that the heat flows in the direction you want in order to, well, get it to your heat sinks. And as we see back here, we have our solar plates next to these boiler heaters, and that's just so that they don't melt down and, well, cause a mess in the test world. So, heat pumps are merely heat pipe, thorium, which is an ore introduced by New Age. This is radioactive in real life. It doesn't seem to have any effect on me here. I know it's used in higher tiers of New Age to create actual radiation reactors, fission reactors specifically, and there it is more dangerous as a fuel rod, but we're not using it like that, so I'm guessing base thorium just has a low enough half-life that this isn't harmful enough for them to have coded damage into the game. And then, of course, another heat pipe. So that is the heat pump. We then have the boiler heater. This is what we are using to convert heat into steam. Normally, you would use a blaze burner under your boiler, and you would have to fuel it using some kind of burnable or a blaze cake to make it superheated. This might also potentially work under recipes in the basin that require heat for mixing. I haven't tested that out yet, so that might be an experiment for a later date. For now, we're just using it to heat the boiler. This one is fairly straightforward. Iron nugget, empty space, iron nugget, empty blaze burner, iron nugget, pipe, overcharged iron, pipe. Then we have the advanced solar plate, which is a row of glass, overcharged iron, pipe, overcharged iron, and repeat that on the bottom as well. Next up on this side, we have Immersive Engineering. When I checked Create New Age, it appears that they don't have any method of actually storing power. Each of these blocks do have its own internal buffer. However, when motors, for example, have power, they will continually turn. And I haven't tried putting a redstone lever on them or anything like that to see if they shut off, but it seems like they just keep going until they use up all the power in the buffers. These motor extensions also have some additional power capacity, but again, I don't know if that's one of those cases where it consumes power if it has power, and that's not something we wanted. Thus, I turned to Immersive Engineering, which, to start, we have this MV accumulator. Now, a little bit about Immersive Engineering is that it has 3 tiers of power transmission: LV, low voltage, MV, medium voltage, and HV, high voltage. You want to ensure that you are using the same voltage level across your contraption. Either that, or you need a transformer to step the voltage up or down to whichever voltage you're targeting. Otherwise, things start to explode. And I don't know if that does surrounding damage, but at the very least it can certainly harm players and other entities in the vicinity, and it will break your system. You will lose the block that is overloaded, and that means that you're either not transmitting power, or you've lost an accumulator. It can be kinda catastrophic. We are opting to go for the MV accumulator right off the bat, just because I have all these resources in survival, and the HV accumulator requires access to materials that we don't quite have yet. It would necessitate getting into, I want to say, graphite and the like, which, again, I haven't processed yet because I'm not at that level of technology in the series from a storytelling standpoint. I'm sure I could get into it if I wanted to, but that's for down the road. So, to make an MV accumulator, you need treated wood planks, a nickel plate. Again, check your JEI to make sure that it accepts the correct tags. This will accept nickel plates from multiple mods, just verify it first. Treated wood planks, steel ingot, which you get from the blast furnace in Immersive Engineering, bucket of redstone acid, which if memory serves is just a bucket of water surrounded by redstone dust in a crafting bench, steel ingot, another treated wood planks, an iron plate, again accepts multiple types of iron plate, and treated wood planks. Over here we have the MV wire connector. This is what allows you to input or extract power from our various devices in this setup. It is 3 electrum ingots down the center, then 2 terracotta in the lower left, and 2 terracotta in the lower right. Then we have the MV wire relay. The thing about immersive engineering is, when you connect this to something, it expects either a direct connection to another wire connector, and that's it. It will only permit a one-to-one relationship, or you can go from one of these connectors to a relay, and from the relay you can branch out and go in multiple directions, I believe. This functionally extends your cable, and we're going to see use of it at least once in our breakout. But you can see it's just 2 electrum ingots down the center, terracotta in the corner, and terracotta in the corner. Second to last, I believe, in the immersive engineering category, we have the insulated MV wire. The reason we're doing insulated is because, well, if this were just regular MV wire, I could walk up to it while it's charged and I could zap myself. And so this is for safety purposes. Low voltage and medium voltage both have insulated wires in this mod. High voltage does not, because, much like real life, high voltage is used for transmitting lots of power across long distances, and so usually you're going to be stepping up and down to high voltage. You're not going to be using this in your base typically, but this is good. It helps protect the user. We have 5 tough fabrics in an X, and then we have MV wire coils in a diamond. These are pretty easy. These are just, you get electrum ingots, and then you flatten them into a plate, cut them with your wire cutters, you get 4 of those wire fragments, and then wrap them around a stick, and that's how you get a coil. You might even get 4 coils out of that. Don't quote me on that. I don't remember the recipe quite off the top of my head. And then last, but certainly not least, we have the redstone breaker. This accepts a redstone signal and cuts the power when it's on. So we have an HV wire connector, a redstone repeater, another HV wire connector, iron plate, electronic component, and this requires use of the Immersive Engineering workbench. And so that means you need a blueprint and a few other materials in order to make this, but it's really not that difficult. You can look this up in JEI as well. And then an iron plate. And then lastly, and the most, well, basic create component of this build that we're going into is the steam engine itself, which is a golden plate, an andesite alloy, and then a block of copper. Now, before we get into the actual breakdown, you can skip certain steps in New Age by using different mods to integrate with. This may not be viable in your particular pack, but in my case, I have access to solar panels, and that means that we can create this really compact setup here, where we have a basic motor here, gearbox here, and a basic Energizer here, and then a solar panel in the corner, and that allows you to feed both of these things electricity. You are going to need these basic Energizers in order to overcharge your ingots. So if I just put one here, we have an overcharged iron. If we put in more than one, it takes proportionately as long. Now we are getting into the actual breakdown of the system. So up at the top, we have an array of 5x5 advanced solar plates. They're not all on the same level. I'm not entirely sure that matters at all, but we could theoretically put this down flat. We could theoretically run heat pipes underneath all of those and then just come across to here. There may be some efficiency gained by doing that. In other words, we're making our route slightly shorter, so maybe there's less heat loss going down these pipes. But you can see that we're still transmitting pretty well, effectively, I guess. Nothing is melting down, is the point, and we consistently drop heat despite being in a desert. I don't know if biome has any effect, but this just indicates the system works fine. Here we have a redstone link just to monitor this daylight detector, which I think is on at night. I believe is how it's currently set up. Yes, because we have toggled that mode. And that is crucial because we don't want our electric starter trying to restart the boiler at night. It's not going to work if we don't have any heat. And we're going to demonstrate later that going to night does, in fact, prevent the boiler from getting enough heat to keep itself going. So, we don't want the electric motor running all night, wasting power. Popping down here, we have our boiler. You can also see that we've got a whole bunch of boiler heaters underneath it. We have 9 steam engines connected to it because on the server we are currently up to level 9. I think we might actually be able to go all the way up to 11 if the heat is stable. And we can kind of see that here with the fluid tank. The heat is fluctuating far more than I expected for some reason. I'm hoping that kind of stabilizes itself. But let's take a look at this broken out fluid tank that we have here. So by default, it starts off as a fluid tank until you place a steam engine on it, at which point it turns into a boiler. You put a few more of these on here, and the thing that we're going to observe is that each steam engine can only take out so much stress, and they can only spin so fast. So as your boiler becomes more powerful, you do in fact need more steam engines. Now, in order to get the steam engine to look just like this, you put down a shaft, and that connects the head of the piston to the powered shaft, and it just kind of looks like this. Now, in order to connect vertically, as you can see over here, we have just a bunch of cogwheels, and I don't know how it does it, but this also ensures that they're all rotating the correct direction. I think it might have just automatically detected it. So yeah, as you can see, this one's rotating clockwise, counterclockwise, and clockwise, which is kind of what we'd expect. And then, I don't want to toggle this on just yet because we want to demonstrate a full cycle. But we can talk about this mechanism next. Here we have our water supply. In the server, we have an aqueous accumulator here. I don't think we really need it. And as we prove in this creative instance, this still functions as an infinite source. I think I just put the aqueous accumulator here because in earlier versions of Create, this block would actually get sucked up and then it would refill with water, so it wouldn't be a constant source. But in later versions of Create, they realized, yes, if you have a block of water that is in fact infinite, then we don't need to really remove it, it counts as an infinite block of water, which, because we have 2 or more blocks of water around this central one, it counts as infinite. You can also see we have a waterlogged pipe here. This could be very useful for other contraptions or possibly like cobblestone generators where you need a source of water, but you also need a pipe running through it. It's a very niche use, but nevertheless, this could help someone. So then we need to talk about the starter and the mechanism that feeds water. And we'll just come over to our breakout here. I legitimately just used a schematic to copy this exact part of the device out. We have here a hand crank. We also have here our strong motor. This can probably be a basic motor now that I've moved it from where it used to be on the server, but before it was like up here or over here on the actual thing. And sometimes it would turn the wrong direction compared to the steam engine. And so that meant that the motor itself was breaking, and I was losing strong motors to despawning because I happened to be away when that happened, and then I loaded it in, and 5 minutes later it's gone. But by putting it down here, we have attached it to this encased chain drive. If we come around the back, our chain drive comes to here, rounds the corner because of how chain drives can bend 90 degrees, and then we have a clutch here. When the system is off, when we're not generating any speed from the steam engine itself, which is what this detects, we have this comparator. And when the comparator is off, the clutch that connects to this chain drive is disabled, meaning that any rotation that comes through this part of the system is transmitted through. Now, obviously, because we're not on the actual system itself, we're not pumping any water, yada yada, that doesn't really matter. But then we come to this encased chain drive, which unifies the 2 different power sources, and we'll loop back in a second. And then we have this nifty variable gear shift design that I found on Reddit. I believe it was Reddit, and if I have the presence of mind, I will naturally include this in the description as well. The synopsis is, we have the adjustable chain gear shift on the top accepting power. Then it goes down into this encased chain drive, and if we come back out the front, we have a belt that transmits it diagonally into another adjustable chain gear shift. So, when both of these receive power level 15, this will double the RPM that's coming in from this chain drive, and then it will transmit that doubled RPM up to here, which will then double it again in this chain gear shift, and then we're extracting that out the bottom here, and then this would normally connect up to this cogwheel, which also connects up to our pump. Now, the reason we've done this is because this rotates at 32 RPM and only outputs 256 stress unit capacity. So we need to ensure that our pump does not consume more than 256 SU when you're manually starting it for the very first time. But then, when this activates, we'll have speed coming out of the steam engine. This is currently set to 50 just so that we can double that, or so that we can quadruple that to 200 RPM, which for the level of boiler that we have is the fastest that you want the water running. Otherwise you're going to be overfeeding it water, which doesn't actually harm the system, you're just kind of wasting SU at that point. But that goes through, and when we're getting stress out of the steam engine, this clutch is disabled, meaning that the steam engine is turning the pump itself. And of course, because we have a repeater coming out of here, this gets powered to 15, and this gets powered to 15, meaning both of these immediately jump from 0, or just one-time multiplicative, I should say, to doubling. And in this case, because we're doubling, it's quadrupling. We will hold off on turning the system until we've gone a full walkthrough, so let's talk about this next. This, broken out, is what I refer to as a stress unit breaker. It's like a circuit breaker, except it cuts off the system when it has too much stress going through it. So, early on, when this was just a level 6 boiler at best, and we only had basic heat plates up there, it would frequently dip down into passive heating, and when that happened, it couldn't sustain itself. The 3 magnetic coils that were turning were too much stress, and so the system would overload, and then the boiler would eventually die because it wasn't getting enough water, and then we'd have to go over and manually restart it because we also didn't have enough power over here to start the electric motor, at least not initially. So I built this to kind of smooth out the signal, and basically we have our input, which would normally come in through this line in the ground, but we have an encased chain drive to bring it up to this stressometer. We then have a comparator, and I don't know if it has to be set to comparator mode or subtraction mode, but either way, I think it functionally is exactly the same in this situation. So we have an analog lever set to strength 14. That means this wire should also be 14. Hold on. There we go. I just had to update it. But that means that any signal that is 14 or less does not get through here. It only goes through if the stressometer is maxed out, and that only happens either A, when you're legitimately at maximum load, which I'm nowhere near at this point in time, or B, you've managed to overstress your system. And so this will max out, this will hit 15, let the signal through into this pulse extender from Create. So for the next 20 seconds, that will turn this on, which will turn the clutch on, which will stop the stress from going into these 3 magnetic coils. And that will give you enough time to run over here and shut off one or more of them, allowing the system to recover naturally. Now, as long as you have enough power, then the system will reboot itself during one of these surges, more or less, but because we do not have anything in the accumulators, ignore this one, this is my second take, but because we don't have anything in these accumulators, we want to start with all of these off, just until the boiler gets self-sustaining the first time around, and then we will come back over here and turn each of these on, and that's when we'll start generating power, and then we'll have a backup, and then we'll demonstrate that we can self-start the system. I believe that's everything. We can dip down here. We do have a rotation speed controller so that we can speed up these coils if we want to. I put this in here so that if we upgrade the coil material, then we can slow this down if the stress becomes too much. And if we just leave it as is, we can also increase the speed because 16 is kind of slow, and we can definitely get more power out of this when we are at level 9 boiler. But under here, and the last thing, we have a gearbox and then a clutch for each of these coils. So that means that we can manually manage which coil is on or off. And in this case, all of them are off because all the clutches are on. Now, for the moment of truth, that's not really a moment of truth, but if I hold this down, we can see the large cogwheel has started turning, and that only happens when we get power out of the steam engine. And of course, as you also saw, this immediately leapt up to 50 RPM once it was self-sustaining, and then the system carried the power through. This is now at 800 stress units, which, if you recall, a pump has 4 times the stress impact as the RPM. So that means we are running at 200 RPM as targeted. Now if we take a look at the boiler, we are at level 8? Okay, there we go. Now we're at level 9. The heat was kind of erratic a little bit, but it seems to have stabilized now. I think that's because I set it time to night for a few seconds there, and it probably cooled down, and then finally it's heated back up. Ugh. It could also be because I've pasted things in and we need updating. Or maybe it's somehow factoring in that cloud that's moving in front of the sun. I doubt it, but we have more than enough stress capacity now that we can go ahead and turn these on. And when we do, we can see the coils are beginning to spin. You can see that each of these carbon brushes is emitting 55 FE per tick. Is it per tick or is it per second? Oh no, yeah, it's per tick. Yeah. And then this accumulator, although we're not actually accumulating anything in here right this second, you can see that power is flowing through it at a rate of 159 FE per tick. And I suspect that this is actually a rounding error, potentially. Either that or we've got an inefficiency somewhere. But we are now accumulating in this accumulator. And if I go ahead and set time to midnight, we should have more than enough power in the buffer. It's time set midnight. So if we just go ahead and do that, we will wait for the system to lose its heat. We will eventually see the engine start to move slower, and then finally die. This is also a good opportunity to indicate how this circuit breaker works, because when the heat starts to die down, we are very inevitably going to dip below the stress threshold. Okay, it is more rapidly cooling now, so we might start to see this system activate over here. And there we have it, the circuit breaker just activated. This has thankfully kept its momentum up long enough that it hasn't died fully. But we can now skip ahead to when the system is fully off, and then we'll switch the time back to day, and we'll indicate that the electric motor is what's being used to start the system. Alright, it appears that we have fully run out. I'm going to get to a decent vantage point here where we should be able to see all of the redstone links activate. So time set noon. And you can see the electric engine has just started at the same time that link stopped. And the electric motor should keep going until we get sufficient heat levels here, which is astonishingly not happening as fast as I would have expected. Now this is filled up, which means that it's going to be spinning for quite a while. But at some point, we should start getting more heat. And the only reason it's behaving as strangely as it is because we are jumping straight from midnight to noon. This doesn't usually happen in survival Minecraft, so you would normally see the heat gradually increase as the morning goes on, and then around noon you're going full tilt. So we're kind of seeing what would normally happen in the morning, just during broad daylight. Heat doesn't increase that fast, at least not the way this mod is coded. But we are slowly getting up into the level that should sustain all three of our breakers, or all three of our coils, I should say. So once this shuts off, it's going to toggle right back on because our heat is still not steady enough to quite maintain all of them. And there we go. We are now at a very stable level 9. Heat is still kind of fluctuating. I have seen it get as high as 10 or 11, just like that. It just briefly hit 11 there. But in order to hit 11, we would need to expand this boiler one level up, and then add a few more steam engines. Because as you can see here, the maximum speed that steam engines get up to is 64 RPM. That's why we have the speedometer. I mean, not the speedometer, the rotation speed controller. That is also why we have multiple steam engines, because they only go up to 16,000 and change stress units. It's one of those powers of 2 that I don't have memorized. There we go, 16,384. And then above this, you need more to extract any additional stress that comes out of the system. And that is going to do it for this tutorial. I hope you enjoyed it. If you did, be sure to like, subscribe, and click that bell to be notified. And as always, I'm looking forward to your feedback, questions, and requests in the comments below. And with that, I will catch you on the flip side. Thanks for watching, everybody! In the upper left is the associated video. In the lower left is the Create Tutorial playlist, and on the right is my icon, by which you can subscribe. Thanks again for watching!